Hey folks, today I'm diving into one of the most iconic equations in the world of physics, E=mc squared. You've probably seen it on everything from t-shirts to coffee mugs. But do you know how this equation changed the course of history by leading to the development of atomic bombs? Let's break it down. First, a little background. EMC squared was introduced by Albert Einstein in 1905, part of his special theory of relativity. This tiny equation packs a punch. It tells us that energy, E, equals mass, em, times the speed of light, c squared. Sounds simple, right? But the implications are profound. This equation tells us that mass and energy are interchangeable. This was a groundbreaking revelation because it showed us that even a small amount of mass could be converted into a massive amount of energy. And here's where it gets explosive, literally. During World War II, scientists began to wonder if they could harness the principle of E=mc squared to create a new type of bomb. This led to the Manhattan Project, a secret research project that aimed to develop atomic bombs before Germany could. In 1945, the world witnessed the power of E=mc squared firsthand when the United States dropped atomic bombs on Hiroshima and Nagasaki. The devastation was immense, showing both the power and the terror of nuclear energy. The core principle behind the atomic bomb involves initiating an uncontrolled nuclear chain reaction. In the case of the bomb dropped on Hiroshima, it was uranium-235. When the nucleus of a uranium-235 atom absorbs a neutron, it becomes unstable and splits into smaller atoms, releasing a vast amount of energy, thanks to E=mc squared. This process, known as nuclear fission, releases an enormous amount of energy in the form of heat and light, energy that originally existed as the mass of the atom's nucleus. The conversion rate of mass to energy is what makes nuclear weapons so powerful and also so destructive. But the story doesn't end here. The understanding of E=mc squared also paved the way for nuclear power, which, unlike nuclear weapons, aims to control the energy release from nuclear fission to generate electricity. While nuclear weapons pose significant risks and ethical questions, nuclear energy provides a more controlled use of E=mc squared, highlighting the dual-use nature of scientific discoveries. They can be used to both end and save lives. So there you have it. E=mc squared isn't just a cool-looking equation, it's a formula that has real-world implications, from the devastating power of atomic bombs to the potential of nuclear energy. It's a perfect example of how a simple equation can change the world. Thanks for tuning in. Remember, science is all around us, influencing our lives in ways we might not even notice. Until next time, keep questioning, keep learning.